So today on the weekly What Is It? On the bench, we have a LED flashlight. It's supposed to go with a Harbor Freight Bauer name brand battery. I talked a little bit on the last weekly What Is It about how when you put 20 volts across this light, it doesn't light up. So what I was trying to do was, I was trying to take this flashlight that I didn't have a battery for and really wasn't interested in getting the batteries for it. How hard would it be to make it fit one that I already have? And it's not going to be very hard to do. I can make it work in several different ways. One thing that I did notice when testing, this is positive and this is negative. If I cut on my supply and just give it 20 volts, I noticed there were 20 volts on these power terminals. It just blinks, it actually won't come on. So immediately I went towards maybe one of these terminals being used to give feedback from the battery that it's okay before it allows this unit to stay on. So apparently with these Bauer name brand, the intelligence and the electronics must be built into the actual tool or device that the battery is supplying. So with that in mind, I thought it was lucky enough to just be resistance like a thermistor, that maybe we can get this going and maybe it'll stay on. So as we look at another type battery, for example, this is a Makita. It's not a good fit for this. It will be hard to make it work, but this is one that I already have a part. We have a plus, a minus, and a TH. And typically the TH means something to do with a thermistor. So if we look at this Makita, we have a TH1 here. And it's just nothing more than a little NTC that is pushed down into close to the battery pack on top of one of the cells there. And it's just monitoring the battery pack and feeding back to a terminal they call TH. On the Makita though, a lot of the intelligence is actually in the pack, because we see here, without getting into too much detail, it's a lot of microcontroller, a lot of SMD components, transistors, a lot of stuff's going on intelligently on this battery pack. So thinking about the thermistor and what they typically are, this just being a NTC on this board, if we just ohm out this typical thermistor, we get somewhere around 9K. You see them, I mean, they can be 1.2K to 14K. I mean, there's a lot of different type of thermistors out there and a lot of different ranges. I'm going to take this apart now and just see which one of these connections is actually used to feed back for the main circuitry. Got a hidden one here. We're going to have to take this off as well. And now we can see our 3 connections coming from the battery connection coming up. So as we have figured out before, we got the positive and the negative. and we can see that the blue one is hooked to the one next to the positive. So we got the possible thermistor, the positive and the negative. And this one's actually not connected. There we go, there's our LED module. They calling it plus minus an N on the connection here. That microcontroller is not marked. There's no markings on that microcontroller. A little bit of a better view of the circuitry on the board there. The actual LED module. So we see that it does have the circuitry like we suspected on the actual device itself. So it looks like we could feed that microcontroller a resistance, and we might be able to make this light stay on. Like their battery might just have a thermistor feeding into this device or any of its devices that they sell. So we'll put it back together and we'll see. All right, now that we got it back together, we put our positive on the positive terminal and the negative on the negative, and we give it 20 volts. Same thing, it won't come on, just blinks. Now what I have here is a 33K ohm resistor. I have a 33 ohm and a 47K ohm. They're higher, but I want to start with higher first. I'm going to go from the negative terminal. So from the negative, do a resistance here. I'm going to try 33K ohm first. From the negative to the thermistor input, at least what I believe is a thermistor input, we'll see. And just with that across there temporarily, and the light comes on. Dim it down, off, bright, low, off. You see that this light has a adjustable lens on it, like a flood and a spot. So 33 works. Does 47K work? Yep, 47K will work. So I would love to hit the middle resistance range of this. So to do that, or to find out what that middle range might be with the resistor, I'm going to bring in this is actually a 100K potentiometer. I just got some jumpers across the wiper in one of the counterclockwise positions. Just lay this up here. I actually have my meter on this. So I'm going to clip one on the negative. I'll use the other lead. I can see the resistance with it unhooked. When I put it across the voltage, it's actually going to show a weird reading when I try to start it. But at least I know it's a 1.3K won't work. There's 8K. Well, 8K will get it. Let's try 6K. Nope. We can take this all the way up to 100K. So we know that 8K, right at 8K, will get it. It seems to work. We'll go on up now. We know that 47K actually worked with the resistor. So we'll go just a little past 47 and try that. Any of this in between should work. We should definitely be in the range. 33K resistor worked. A 47K worked. As we approach 48 to 49K, we still work. 50K. We are still working at 50K. A little over 52. Still working, that's surprising. A little over 54K. It tried to come on a little more than the typical blink, but I think that's the limit. It won't go to 55K. So we call this 10K to 50K. I think we're in a safe range. Jumper jumped off. So here at 9K, we'll hold a good connection. So now I know that anywhere from 10K to 50K, I'll probably shoot for somewhere at 25K. I'll just put a 25K resistor across the thermistor terminal and the minus or the negative battery terminal, and I'll be able to get this flashlight working on any 20 volt battery or any 20 volt source that I choose to use. I hope you found this video useful on trying to figure out what the terminals were on this flashlight. I hope you've seen how useful it was to try to figure out the terminals on any cordless power tool or device. So as simple as figuring out what the thermistor terminal would be, we can get this flashlight working on any 20 volt source. On the next weekly What Is It?, we look at this. So what is it? Hope you enjoy the video. If you liked it, please give it a thumbs up. Please subscribe, and thanks for watching.